This is exam 1, fall 25 for physics 101. As first is a free fall question. I throw a ball up in the air with a speed of 25 meters per second. So it goes up, comes back down again. I know that the initial speed is 25 meters per second. Um, I want to know, I also know the acceleration is negative 10 meters per second squared. I know that the velocity at the top is equal to 0 meters per second. And I also know that the time required to go up is equal to the time required to go down. So first I want to know the total time that is required, that is in the air. I know that v at the top is equal to v naught plus a times t at the top. These two are linked, right? Because this is a parametric equation that to find v at the top, I need to know what t is at the top. But I know actually what v at the top is equal to 0 plus 10, excuse me, negative 10 times t at the top. If I solve that, I get that t top is equal to negative 25 divided by negative 10. So that's positive 2.5 seconds. Right, so that means that the answer to part A is twice that value, or 5.0 seconds, because it takes 2.5 seconds to go up and then 2.5 seconds to come down. So the total time in the air is 5 seconds. What is the maximum height? Well, I know that the t top is equal to 2.5 seconds. So I just want to know what is the height at that particular time. So I say that y is equal to v naught t plus 1 half a t squared. That's equal to 25 times 2.5 seconds. Let's see, I know that time. When I do that, I get, let's see, 25 times 2.5 minus, get 31.25 meters, keeping two sig figs, so 31 meters. That's the height, the maximum height that it goes to. And I'm going to know the velocity of the ball at 4 seconds. So to find that, I say that the velocity is equal to v naught plus at. I'm just going to let this time equal to 4.0 seconds, and that'll give me that velocity. Our initial was 25 minus 10 meters per second squared times 4 seconds. So that's equal to 25 minus 40 equals minus 15 meters per second. That's the answer there. Now note here that that occurs, on this half of the trajectory that it has. When I say the answer was minus 15, that it has that velocity along there. And then the final part is I want you to give me the position versus time graph. That position versus time graph will look like this. It starts out with a big positive velocity or a big positive slope at the top. That velocity goes to 0, and then it ends up with a big negative slope. All right, truck covers 400 meters. X is equal to 400 meters. T is equal to 10 seconds. It slows down to a stop. That means that V is equal to 0. I don't know what V naught is, and I don't know what A is. So I want to set up a system of equations in order to find V naught and the acceleration. I'm just going to write out my equation. I'm going to write them with these numbers. So 400 equals V naught times 10 plus 1 half a times 10 squared. And then also v, that's 0, equals v naught plus a times 10. That's the time, right? Yeah, 10 seconds. And now I want to solve, well, this one's easier to solve over here, so I'll just solve this one for v naught. V naught is equal to negative 10a. I subtracted 10a from both sides. And then I can put that in right here. So I have 400 equals negative 10a times 10 plus 1 half of negative, of a times 10 squared, which is 100. Let's simplify this a little bit. 400 equals negative 100a plus 50a, or 400 equals negative 50a, or a is equal to 400 over negative 50, which is equal to negative 8 meters per second squared. Actually, I think it should be negative, I think it's 8.0. I wasn't really checking sig figs there, but that's the right answer. 8 meters per second squared. Okay, so need to show your work on this, of course, and I need to see these equations solved in this way. Also recognize that that negative makes sense because it's starting out with a speed and it's slowing down. It's starting out with actually with a positive speed. We need to finish that actually. So V naught here is equal to negative 10 times the acceleration, which I now know, which is positive 80 meters per second. So it starts out with this positive velocity and it's slowing down, so that means it has a negative acceleration. Let's see. Here, what is the instantaneous acceleration at t equal 4 seconds? I would take a range of answers, but I'm looking for the best fit line at this point. I'll probably take something like that. I'm going to sort of fudge it and make it go right there. Uh, and then I want to find the rise over the run. The rise, as I've drawn it here, is 8. The run looks like about 1.2 or so seconds. This is 8 meters per second. So to find the instantaneous acceleration, that's going to be delta V over delta T, or that is the rise over the run, 8 over 1.2, which is 6.7 meters per second squared. And then also it's really important for me to realize that this is a negative slope, so I'm going to put this negative here. That negative, by the way, would come in mathematically here on the 8 because my change in V is a negative 8 meters per second. And then I also want to estimate the distance traveled between, well, this whole duration of motion. I'm going to recognize that each of these squares has a distance traveled of 2 times 1, so it's 2 meters. Let's just count the squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have 14 complete squares. And then I can add them up. Like see this one, and this one make another square. This one and this one make another square. I would say this one and this one make another square, and then I think I just have this half square here, so I have about a half. So that means I have, what's that, 17 and a half squares. Each of them is equivalent to 2 meters, so if I multiply that times 2, that's 35 meters. All right. Both of those, there was some range of answers that I would accept, but they should certainly be near to those. All right, that's the free response. What is the area of a quarter in square millimeters? So if I think about a quarter, it has a radius of approximately 1 centimeter, about 1 pinky's width. So that's pi times 1 centimeter is equivalent to 10 millimeters. So pi r squared, that's pi times 10 squared. That's 100 times basically 3, or 300 millimeters squared. The mass of a typical man is 70 kilograms. Which of these equations is dimensionally correct? All right, so I have meters per second squared times seconds equals meters per second plus meters per second. This one cancels with one of those, and all of those are correct, so they all match. Here, I can get rid of my m. That goes away. Remember, I don't worry about the 1/3. So I have v, which is meters per second, and then a, which is meters per second squared. And then over here I have meters squared over seconds cubed. But I also have meters squared over seconds cubed on this side, so that one is dimensionally correct. And then here I can get rid of my m's. Don't worry about the half. Meters per second squared equals g is meters per second squared. It's a form of acceleration times meters. So those are both meters squared per second squared. So E is the right answer. Here, if A is equal to BX, what are the units for B? A is equal to BX. That means that B is equal to A divided by X. That's meters per second squared. 1 over meters, so it's 1 over second squared. This D is the right answer. What's the correct answer for this? Well, if I do this in my calculator, I get this answer, but that's not right. So I have 7, what's that, 8.55, or 8.6 divided by 2.22. And then if I divide those two, I keep just 2 sig figs, so the answer should be C. Unit for the kilogram is Planck's constant. Here, helpful to draw this triangle. You'll certainly need it for the next one. Use Pythagorean theorem. Get 4.3. So A is the right answer for number 7. And then I just want to know that angle that's opposite the 2.5 meter side. That's this angle right here. So I know that tan of theta is opposite over adjacent. So I solve that, saying theta is the inverse tan. I get 36 degrees. C is the right answer. All right. You have a very similar question on your quiz for this. It's just a little bit different. I'd like to go ahead and convert the feet squared to acres. I'm just going to make this conversion factor up here. 66 feet times 660 feet is 43,560. That's 1 acre is equal to that many square feet. And I want to convert these 20,000 acres to feet squared, or excuse me, to what square kilometers. Um, I know that 1 acre is 43,560 feet squared. Notice I don't square this conversion term because the acres are not squared. The feet are, but, and then I'm going to convert my feet. 3.28 feet is 1 meter. I do square this term. That's in square meters now. And then I want to convert those meters into kilometers. I know that in 1 kilometer there are 1,000 meters. You just need to know that. And I do need to square that term. And if I do that, I get it's 80. 43,560 times 20,000. Yeah, 80 kilometers squared. All right. The SI system uses which of these for mass, length, and time? That's the MKS system. That's kilogram meter second. Oop. Fastest 100-meter time, write down what I know, is about 10 seconds. If the runner continuously accelerates, what is their final speed? So I want to know what is V final. I know that V is equal to V naught plus AT. I know V naught is 0 here. They will start at rest, but I don't know A, so, and I don't know T. I do know T, but I don't know A. So I need to figure out what A is. So I can say that X is equal to V naught T plus 1/2 AT squared. This goes away because V naught is equal to 0. So 100 is equal to 1/2 of A times 10 squared. So that cancels with that, leaves 1. So A is equal to 2 meters per second squared. So what is their final speed? It's going to be 2 meters per second squared times t, which is 10 seconds, which is equal to 20 meters per second. That's pretty fast, right? So probably sort of like the car problem that we did with the race. If I look at the V versus T, like I'm assuming that the person runs like this with a constant velocity, excuse me, with a constant acceleration, but likely what happened is the person really runs sort of like this, where their acceleration slows down as they get faster. It's very difficult to maintain a constant acceleration while you're moving. All right, you throw a stone upwards, it requires 2 seconds. To reach the top of the trajectory, what is the maximum height? I know A is -10. I want to know what Y is. Um, I don't know what V naught is here. So I'm going to have to figure out what V naught is, but I do know that V at the top is equal to 0, and that T top, that's this 2 seconds, so T top is 2 seconds. So I need to figure out V naught. So I say V top equals V naught plus AT, that's 0, equals V naught minus 10 times 2. So it means V naught is equal to 20. So now I can solve for y. 20 times 2 plus 1/2 of -10 times 2 squared. That's 40 minus 20 is 20 meters. C is 12. All right, I might draw a picture for this. So this is x equals 0 right here. He moves 70 meters to the east, that's to the right, 120 meters to the west. It means that this distance, by the way, is 50 meters. And then he moves east again a distance of 90 meters. So if this is 50, that means that if this distance is 50, that means that this final distance is 40, that he is 40 meters from the origin. So that's going to be D, and it's positive 40 because it's past x equals 0. Statements about it's true, speed is magnitude velocity, that's true. That's true. This is not true. You can have an object with negative acceleration that is speeding up. Imagine have an object that's going up and coming back down. On this side of the trajectory, it has a negative acceleration and it has an increasing speed. Okay, sorry, I had a call. So an object with negative acceleration is always slowing down. That's not true. An object is speeding up. Its acceleration is always positive. Well, that's not true either. That's like the opposite of this other statement, and that's not true. So only 1 and 2 are true. This object, what is the velocity versus time graph? Recognize that I have a negative slope, so that means that the velocity is going to be negative. That gets rid of that one, and that one, and that one actually, because it's always negative, and it is an increasing negative slope. This has a negative value and a negative value that is increasing, so A is right. Okay, this is a position versus time graph. Which of these statements are true? The velocity at A is constant. Um, I would say that's true because that is a pretty straight line right there. So, but there might be some debate about that. But for now, we're just going to say 1 is true. Let me show you a good tip. Most of y'all know this. If 1, well, actually, let's not do that right now. So the acceleration of B is positive. So notice here that the velocity, the speed is decreasing. So I have a decreasing speed, and it is a positive velocity. That means it has a negative acceleration. So 2 is not right, definitely not right. That gets rid of that one, and that one, and that one. So it's either 2 and 3, or 1, 2, and 4. Remember, I have a little question about 1. I think it is constant because this looks like a straight line at this point. But if you're not sure, then we can look at 3 and 4. The velocity at D and C are 0. D and C are at the tops of these. So the tangent lines are 0. So yeah, that one's true. Let's look back at our options. We'll see that gets rid of that one. So the answer has to be B. Let's just look at 4. The object is speeding up at point E. Right, it has a slope that looks like that, but that slope is getting smaller, so it's not speeding up, it's actually slowing down. All right, shows velocity versus time graph for 3 separate cars. We did a problem like this in class. Which of these statements is false? They all reach the same velocity. That is true. They all reach this velocity. car A has a larger acceleration than car B. That is true. See, this slope is a lot bigger than this slope. Car C finishes with a larger acceleration. This slope is bigger than this slope, so that's true. That means that this cannot be true. In fact, C covers this distance, B covers that distance, and A covers the largest distance of all, the area under the graph. All right, what is the velocity here at 2.5 seconds? Just find the slope of this line right here. That's a rise of 10 to 50, 40, and a run of 3 minus 2 is 1, so it's 40 over 1. It is negative, so A is the right answer. And then what is the average acceleration from t equal 20 to 60 seconds? Oh, that's easy, look, because the velocity is the same at both of those, so it's 0. And then estimate the distance traveled between 30 and 40 seconds. Just like we did before, I want to know this distance. Each square is 100 meters. That's because it's 10 by 10, right? 0 to 10, 30 to 40 is 10 by 10. So it's 100. And I have 1, 2, 3, 4, and then, I don't know, 4.7 or 4.8 or so. So the answer is A.